is Josh. I'm going to be going through all these different types of angles today. And let me just say this to start this lesson off. There's a lot up here on the board. If you look at these and you say, oh, dude, I totally know all of these, then that's awesome, okay? I want to spend the majority of the lesson going through these just to make sure you really have the vocabulary down, because it is, at least in our book, it's lesson 11.1, which is kind of like the beginning of the chapter. And this chapter is all about angles. And so if you look at these and you go, I've been doing that since 5th grade or whatever, since I was 2, who cares, okay? The bottom line is at this point, you need to know this stuff and you need to be able to apply it to actual math problems. Up until now, maybe you've just been kind of doing a little bit of this stuff, but these rules are important and they are going to show up again in Algebra 1 and Geometry and a little bit even beyond that. So now that I've kind of said my disclaimer, let's get into all of these things, okay? So I wrote them all down. If you know what they are, then great. Maybe just move through the video, or maybe just kind of take a guess and write down what you think they are and then check with me. Now, I will say that my lines are fairly straight. I do this a lot, so they're fairly straight, but they're not always going to be perfect. Okay? When it comes to vertical angles, we're talking about angles that are, I guess you could almost say they're opposite each other. So we have an angle here. The opposite angle of that guy would be this guy down here. And the main takeaway for vertical angles is that they are congruent. I guess I should have wrote that down here, but I'll just write it here. Congruent, right? That means that they are the same measure, okay? So if this one up here was like 42, well, I guess it's like almost 82, I guess. We'll say if this guy was 82 degrees, then we know these vertical angles are equal. Therefore, this guy down here is 82 degrees. Now, because this chapter is all about degrees and measures, I will say, I'm going to, at least for my students, I'm going to call you if you mess up with these degree signs, okay? The whole chapter is on degrees, so just start practicing it. Okay, moving on from vertical angles, let's do some adjacent angles. And I'm just going to kind of erase these and redraw them every time. And the book goes through all this as well. So I have this guy, I got this guy here. I'll just kind of draw out a bunch of these. I think that's what the book did. They just kind of labeled some angles here as like angle 3 and 4, okay? These two angles are considered adjacent. The main takeaways from that is that it shares a line, okay? Our book says that it has the same vertex, which I thought was a little bit tricky because vertices are kind of like where two parts meet. So we could say that. So that's why they say it has this, they share the same vertex because they kind of share this one spot right here. I would rather just rely on the fact that you understand that they share a line, they're next to each other, okay? And the last takeaway for adjacent angles is that they don't overlap. So this guy here, if I were to like take this one out and kind of like move it down here and then take this guy, and I wouldn't put it and say, well, I'm going to take these two and I'm going to move this guy. I'm going to draw it like, oh, that marker's done. I'm going to draw it like this and go like that. So they kind of like overlap each other. Adjacent angles have to be right next to each other, but they share that line. They don't overlap. Those are the main takeaways. Okay. All right. So now we're at complementary and supplementary. In my class, spelling doesn't count, but do your best. I mean, at this point, in this age, like you should be able to write these words. I personally don't call you on it if you biff it, but at the same time, practice spelling complementary, supplementary, just because they're things that you should be able to spell at this point. Complementary angles, I guess I'll just draw one like that. Are two angles, but they're very kind of special angles. Let's see here. Let me draw another line like that. Okay. These guys are special for two reasons. Not only are they a different type of angle, they're what? Adjacent angles. Yeah, they are actually. Oh my gosh. We're coming back to the second thing we did. But not only are they adjacent, but they are also, let me kind of draw this a little bit. Like that. Okay. There's a little symbol, and I kind of get down to that over here as well, okay? Complementary angles equal 90 degrees. So no matter what this guy is and this guy is, we know that this entire span between the two angles that are adjacent equals 90 degrees. So if this guy was 30 degrees, then we know that this guy over here is 60 degrees because we know that they're complementary, therefore we know that they equal 90. Now this is where the vocab gets important because in some of these problems they're just going to tell you stuff and assume you can relate that and then go, oh, okay, now I know what they're telling me. Because they might give you some crazy picture with all these angles and stuff and say, you know, these ones are complementary, these ones are supplementary, figure out the measure of angles, something like way over here. And you're going, oh man, how do I do this? But think about the vocab, right? Vocab is telling us complementary means that the two angles are going to equal 90 degrees. So rather than actually drawing this out and saying, dude, it's 90, they're going to give you these little clues and vocab. The other thing they're going to do is when we have 90-degree angles or complementary angles, they're gonna draw these little lines like that little box. I'm sure you've seen it before, which just tells you that this measure in here is 90 degrees. And a lot of times they do that in pictures because they're not to scale. So it's just an easy way to say like, hey, just assume this is 90 because I'm telling you. And the way they tell you is they draw that little box down in the corner. Okay. Moving right along to supplementary. Okay, let's see here. I'm going to draw, let's see here. I'll just draw another one like this, and I'll draw an angle like that. Okay, let's say we had these lines here. Okay, supplementary. The way I was taught was like supplementary is a bigger word than complementary, so therefore supplementary is the big angle. And when we have supplementary angles, it's pretty much creating a straight line, which is 180 degrees, okay? So complementaries are 90, supplementaries make 180. So if this guy over here was 40 degrees, we know that this adjacent angle, again, we're using our vocab, the adjacent angle to this 40 degrees is going to be 140 because we know that the total combined amount is 180. This, again, is where the vocab starts coming into play in these problems because they're going to say, well, this value over here is like x plus 7, and this over here is like 2x minus 5 or something. And so what is the measurement of x? Or like, what is the amount of this angle right here? And you're like, I don't know. But if you know that they're supplementary, which they'll usually tell you in the problem, then you have something to work with. And we're going to get into that as we do a couple of the problems from this chapter. So supplementary means straight line, 180 degrees. The two angles combined make 180. All right. Where are we at now? Looks like parallel and perpendicular. Okay. So let me draw these guys out here. Parallel lines are just going to be two lines. Okay. Now, we could get all technical and talk about how, they both have the same rate of change. They have the same slope. They will never intersect. There's a lot of different ways to define parallel lines. The main thing we want to take away is the part, like I just said, they're never going to cross. They're always just going to kind of run right next to each other. And because they have the same rate of change, that's just another reason as to why they will never meet up at some point. Okay? So that's what parallel lines are. And then we have perpendicular lines. So pretty much like the XY axis, right? Perpendicular means they're going to crisscross at a 90-degree angle. A lot of times you'll see that little box in the corner, which shows that it's a 90 degree. And if we know this guy is 90, we know the opposite one over here is 90. The one opposite is called the what type of angle? So close. I know I'm going kind of fast over parts of these, but again, practice the vocabulary. It's a vertical angle, right? Because this guy and this guy are the same. and these are both 90s, and if these are both 90s, and I have a straight line, then the supplementary angle to the 90 over here would be another 90, and another vertical of that would be another 90. And at that point, you're probably going, dude, slow down. You're doing too many verticals and adjacents and complementaries and supplementaries. Take your time, okay? So again, the reason I'm saying all that is I want you to understand that a lot of these terms tie into each other, and the vocab gets important when it comes to solving word problems that deal with this stuff, okay? The next thing here is transversal. And really a transversal is just a straight line, and most books just call it a line. I usually say straight, but it's a straight line that intersects another line, okay? And so a transversal could go through one or more lines. So I guess I could have these two and I could draw a line like that. So that would be a transversal because it goes through this line right there and right there, okay? And that's pretty much all we need to know in terms of transversals. They're just lines that kind of like float through different other situations that are going on. All right, and these ones got kind of long, so I don't know, I just kind of got lazy and decided, well, I'll just write down the main words and then kind of go from there. And then the pictures in the book got all crazy, man, with all these like lines and things that they were doing. Okay, so let me draw this out. I got my two lines here. We'll call these guys A and B. And so I have two lines, and I'm going to tell you that line A is parallel to B. And different books do this different ways. You know, A is parallel to B, right? They're telling you, and again, we need to tell you these rules because otherwise, technically, you could be like, well, that's not solvable because you didn't tell me that these lines were parallel. You didn't tell me something was equal to 90 degrees. And so we have our two lines that are parallel. I got this thing that crosses through them, which now, because of our amazing vocab skills, we know that that is the what? Transversal, right? So we have a transversal going through this. So a lot of times on the assignment, homework, whatever, it'll say line A is parallel to B. Transversal C, you know, goes through both lines. Okay, cool. And then they'll start labeling all these angles like 1, 2, 3, 4, 5, 6, 7, 8. And then they'll say, okay, now tell me about all these angles, okay? And so we have the AIA, which is the alternate interior angles, okay? And let me just grab my little book here, make sure, because we have so many of these things going on. When it comes to alternate interior angles, okay, they alternate, but they're also on the inside of what's going on here. And so alternate interior angles could be listed as like that and that, because they're alternating. It's kind of like this side of the line, that side of the line, this side of the line, that side of the line. But they're also interior because they're like on the inside of the situation here. These guys on the outside would be the opposite, which means they would be the exterior lines, okay? Which actually brings us to our next topic right here. AEA is alternate exterior angles, okay? So some alternate exterior angles, let me just double check here. We could say, could be like this guy and this guy, right? Because they're alternating, they're opposites, like on both sides of the transversal, and they're also on the exterior side of whatever is going on here. And then the last one here is corresponding angles. And those are angles that are just kind of like in the same spot. Okay, so if I have angle here, let's see here, I'll do angle 4 right here. Okay, another one that would be corresponding to that would be angle 8, right? Because they're kind of like, I have two separate lines here. I have the transversal. This guy is in a specific spot between 1 through 4, and number 8 is in a specific spot. They're corresponding to each other. They're kind of like in the same space, okay? That's the main takeaway for that. All right. So now comes the crazy part. I'm going to try to draw these pictures as fast as I can, and maybe I'll throw in a joke or two if I have time. I didn't know how long this was going to take, and like I said, man, we do this in one take, right? We're doing this to solve these things and be good to go for the day. All right, so we got June here. June is cutting a corner of a piece of a rectangle tile. Let's see here. It looks like there's a little bit of a break right here where they have that and that. And really what they're trying to show you is like the piece got cut off. Okay, oh, that's kind of bad. That's okay. But they just wanted to show you that like these two guys were cut apart, okay? Hopefully by now, when you see the picture, you're already starting to think to yourself, what type of angles do I have? What's going on in this situation, okay? And then let's read what they tell us. Okay, boom, sentence number 1. The angles are supplementary, which means that this guy and this guy is going to equal how much? 180, okay? And it says, let's see here, the measure of angle Y, so they labeled this guy Y and this guy X. The measure of angle Y is 135 degrees, okay? Now, could you eyeball this and just say, well, I know 135 plus something is 180? Yeah, you can. Like, I would say get in the habit of solving these algebraically just because it's good practice. You're never going to... You're going to need to solve things algebraically for the next, like, I don't know, at least like 2 or 3 years. So you might as well just practice, whether it's angles or percents or square roots. Like, the rules don't change. So the more you practice it, the better off you'll be. Okay. So I know that I have a situation here. They write it out kind of long, so I'm just going to shorten that. I'm going to say 135. And if you wanted to, you could write degrees as well. So 135 degrees plus x degrees equals 180 degrees. And the reason I'm writing it out like that, and the reason I'm doing it algebraically, like I said, is because it's just good practice. And as the problems get more complicated with more stuff going on, it's going to be in your best interest to be able to work through it mathematically, algebraically, versus just looking at it and going, well, I think it's like 2.6. Like, that's going to take you forever. So just practice writing them out and solve them in that way. So I need to get all my numbers to one side, my x's to the other. So I'm just going to do the opposite of whatever's here. Positive 135, subtract 135, minus 135. So x equals 180 minus 135 is 45 degrees. Make sure you circle your answer and you're all set, okay? And the book then says, if you want, you could be even more specific and write it out as the measure of angle X is 45 degrees. And that looks even more correct, I guess, or more scientific, however you want to say it, okay? The measure of angle X, and again, that's just how you write it out, the measure of angle X is equal to 45 degrees, okay? I would say this is the most correct. If you're kind of struggling with how I solved it, and if you know what, you work on it and you get to this, I would personally say that's good enough, because at that point I can teach you how to write the letter M and the angle sign. You know, we can do that later. But for now, we got to focus on the hard stuff, right? Okay, so that was example number 1. Let me erase all this. While I'm doing that, I guess I got time to share a little something. My wife, she wanted me to brighten up the garden the other day. So what did I do? I planted some bulbs. Well, I hope you got the joke. Some people are probably still sitting there going, I don't get it, dude. You planted some bulbs, right? But she wanted me to brighten up the garden. Okay. Well, maybe, it's hard to tell jokes, like I said, when your audience is just kind of watching and listening. Oops, that line wasn't too big. Oops, that's okay. And let's see. Oh my gosh, there's so many angles on this thing. This is when having these pre-done is kind of nice, but I try to make up for it and just draw them as fast as I can. Okay, so it says here, A and B. A and B are parallel. Okay, boom, done. Q and R, this one is Q and this one is R. Q and R are transversals. Okay, that's cool. I'm good to go. And then sometimes you'll see these little arrows, like this one puts them in red, these little arrows. Really what they're trying to show you is like, hey, the lines are kind of like both going up. Okay, you don't need that right now, so don't worry about it. It says classify the relationship between angle 3 and 5. Okay, so this guy and this guy. Now the nice thing is you're in my class now, and we just talked about those types of angles, and that kind of falls into this category down here. Okay, they're on the inside, so they're the interior angles, and they alternate from one side of the transversal to the other. So these guys are going to be alternate interior angles. Let's see here. Next it says, if the measure of angle 1 is 120, and let's see here, if you know that, then find 5 and 3. Okay, so we know that this guy here is 120. And we know, according to our vocab, that vertical angles are equal. And 1 and 3 are vertical angles. So if this guy is 120, then we know that this guy is 120. And I know if this guy is 120, then I know that this guy is 120. Now, they wanted you to start here and understand that we could go to a vertical angle, and then from there we could go to an alternate interior angle. If you want to be like next level genius, then you could have said, well, yeah, but like 1 and 5 are in the same place. What is that word, man? What is that word that means like when two angles are in the same spot? I don't know, we just talked about it. Those are corresponding angles. So 1 and 5 are corresponding. So you really didn't need to jump from this and go alternate interior. You could have just said, well, 1 and 5 are corresponding angles. So therefore they have to be equal to the same thing, which is 120. And let's see here. So it looks like for that guy, we are good. It says, yeah, I guess that's about it. And then it has you do a couple extra problems, like, tell us about angles like 11 and 15. Okay, well, those guys would be corresponding, right? Because they're in the same spot. And if the measure is this, then what would this be? Okay, since I drew this amazing picture, what could I also say? Well, I got angles 13 and 14 here, okay? They're part of a straight line, so I know these are 180, and 180 degrees but added up between two angles is what type of angles? Hint, hint, hint. Oh yeah, supplementary. Remember, it's the long word. Supplementary means 180. If they were equal to 90, then yeah, it would be complementary. Okay, so let me erase this guy and move on to the last one that I'm going to do. Let me kind of erase some of that stuff. Okay, now we're kind of getting into the math, which is the fun part, I think, because, once you memorize this, you're kind of good to go. Let's see, we got that, and that. Okay. And let's see here. This guy is 2x plus 23 degrees. Oh, that's crazy. And then we got this guy is x. And then I got a bunch of letters that kind of show me like, this is like angle ABC or ABD, whatever. Okay, that part we don't really need yet. Okay. In the figure at the right, measure of, I guess we do just so we can kind of say here, this is ABD, and that's C. Okay. So, in the figure at the right, the measure of angle ABD, okay, ABD is 164. Now, some people like to write those lines on the bottom. I personally say, you know what, draw these as big as you need to, and then mark them up, okay? Do what you're gonna what's going to help you be successful. For me, in my brain, it makes it a lot easier if I draw this giant rainbow through the whole thing and just write out the degrees, what they tell me. And that way I can see, oh yeah, the whole thing here is 164, because that's what they tell me. Now it says find the measures of ABC. And so we go ABC and then CBD and come up with the measures of those. Okay, so I know this guy over here is a bunch of this stuff, and I know that this guy is just X. And I know that combined, or when I add those two together, I get 164. I just kind of talked through the problem and how we would set it up. All right, I have 2x plus 23. Let me put this down to kind of move that out of the way. I have the first guy, right? And then I have plus x, because that's the next part. And I know that all of this is going to equal 164. Okay? I can now do a little bit of math here. I can combine like terms. So I can combine my 2x plus an x and get 3x. Now, these are all in degrees, but like I'm not going to worry about degrees or any kind of measurements until the very, very end, just because right now I want to focus on like how I'm moving stuff around. Okay, let me subtract 23 from both sides, because again, I want my x's on one side, I want my numbers on the other. And hopefully if you've watched a lot of my videos, you notice that I say that all the time, and that's because it happens so often in pre-algebra and algebra, and even a little bit after that. And then by the time you're in calculus, you're like, dude, it's the same thing again. The rules don't change. I'm always moving stuff from one side of the equal sign to the other, and I'm adding and subtracting to do it. 164 minus 23, I don't know, let's just do it. 1, what's that, 4, and a 1. 141, okay. Let's divide both sides by 3. Okay, and I get that. Let's see here. We read our fractions down. 141 divided by 3. So if I wanted to rewrite it, I could. What's that? 4 and a 12, 21, 7. Okay, now again, you should have a calculator. I'm hoping you do. I did it long, just long division. But we read our fractions down. 141 divided by 3 equals, and we get 47. Okay, now let me just double check. Looks like we're on the right path. But the problem here, or I guess I should say the one thing you really do need to check, is don't just circle your answer with these problems and then just be done. Go back and reread the question, because the question was asking something very specific, which was find the measure of ABC and CBD. Okay? ABC, this first angle right here, is 2x plus 23. Okay, so if you just answer at 47, you're going to miss parts of the problem. And I personally would mark you wrong because you're not paying attention to what I need you to do, right? You're doing all this amazing math, but then you need to apply this into the actual problem and do even more. Okay, so now I need to figure out, well, what is that measure? I know it's kind of big. There's two ways I could do this. I'm going to go the long route first, okay? So I plug in my x value, and I'm going to plug it in right there. 2 times 47, what's that? Oh my gosh, 2 times 47 plus 23, what's that? 14, 8, 9, 94 plus 23. Let's combine those guys and get a 7 and an 11. Hey, 7, 11. 117, okay? So I know that the measure of that angle, let me just double check here, is 117 degrees, and it looks like it is. So now is when you could start rewriting this stuff. And again, you could use that proper technical way. The measure of angle ABC is equal to 117 degrees. That's the proper way to write it out. And then I got to do the other one here. But the nice thing is for this problem, x is just the answer, right? The measure of angle CBD is 47 degrees, because they're just telling you whatever x is, that's your measurement and you're done. Okay? And so for that one, it was kind of nice. Now, as the problems get more complicated, this might be this, and this might be like x squared plus 5, and then you got to do work for both of them. But for now, in the examples, they just want you to see how to work through that to come up with your answer. Now, I know some of my students would be saying, dude, if I know this whole thing here is 164, and I know that this guy is 47, then can't I just say 164 minus 47 and get 117 as the other part? Yes, you can. Okay, it works every single time. The process, though, is going to be worth learning when it comes to plugging into these values and just making sure, because you're going to get more complicated stuff in here. And sometimes, like I said, if you knew this was 47, so you were able to subtract it from the big number up here. But if this was like 2x minus 3.6 or something, then you're like, I don't know what to do. Like, I don't know how to figure out that, so I can just subtract it. So that's why I wanted to make sure we followed the process. We plug it back in to one of them or both if necessary to solve for our values. Because if you do the shortcuts, like it only gets you through like example number 1. It's not a very reliable way to finish these problems. Okay? All right. So let me know if you have questions. Great job following along. Make sure you know this vocab, okay? It's good stuff. These are real things that you're going to be needing throughout these lessons, okay? Tune in next time.